Hi everyone. Now we are going to talk about the Newton's laws of motion. First one is the first law of motion. Before talking about the first law of motion, let's talk about the important word, that is the inertia. What is the inertia? It is the tendency of an object to maintain its state of motion. What does it mean? As you see in the figure here, there is a driver and he fastened his seat belt, and there is some movement. I will explain this. Let's say this guy. Actually, here we have one guy, not two guys. Let's say this is our car. Not very good car, but that's okay. This first guy and the second guy, they are same. Let's say this car is moving in this direction, right direction, according to you and me. While going in the right direction, if the driver apply sudden brake, what will happen? Every day you are getting in the car, and sometimes you are driving and sometimes you are passenger. In this case, in the case of the brake, always we observe our body move forward. What does the mean of forward? The direction of the movement of the car. So here, as you see at the second picture, the body of the guy is moving forward towards the direction of the movement of the car. So why? Because when the driver apply the brake, the velocity of the speed of the car decreases. But our body has not any brake. Let's say the car is moving with the 100 km/h. When the guy apply the brake, after brake, sudden brake, let's say the velocity drop 70 km/h. But our body at that moment, it doesn't drop directly 70. So the body, the human body, try to keep 100 km velocity to the forward. Because of that, our body trying to move forward. But we are in the car, we cannot go out of the car. But in the case of crash, for example, the velocity of the car is again, let's say 100. In the case of crash, the velocity of the car drop directly 0 from 100 to 0. So it stops instantly when it hits anywhere. In this case, let me change the color of the marker. In this case, the velocity of the guy in the car, it is 100. So what will happen? The body of the car may move from out of the car from the frontier class. Maybe you have seen some types of video about it anytime, but this is important note why we need seat belt. So we have to fasten our seat belt when we are in the car, either we are driver or passenger, it doesn't matter, we have to fasten our seat belt. So in this types of case, our seat belt will keep us inside of the car. Now let's talk about the Newton's first law. Newton's first law says if the object at rest, it stay at rest, or if the object moving, it tend to move, its motion continue with the constant velocity. Now I will give you another example from the vehicle. For example, let's say we are in the vehicle. This is a bus, let's say, and there is one guy in the bus. Let's draw it better. Yes. So if the velocity of the car at the first, let's say it is 0, that means it's not moving. When the car vehicle starts moving in a right direction, what will happen if the guy is standing up? It might move in the opposite direction. Like when you are waiting at the traffic light, when the light turn on the green, in this case, when the driver apply the gas to the vehicle, so your body move backward. And after a while, let's say the velocity of the car reach 60 km per hour. In this case, what will happen? If there is any brake or sudden brake, it doesn't matter, the body will tend to move forward. Why? In this case, the guy also moving with the same velocity of the car. So if you apply the brake, the car has braking system, but the guy inside of the car has not that same braking system. So because of that, the body of the guy will try to move forward. So this is called first law of motion. And if the object at rest, it remain at rest. If the object moving or in a motion, it try to keep its motion. Because of that, inside of the car, we are using seat belt. Here, there is another note, an important note, when the net external force, in the next page I will explain more what is the net external force, is 0, acceleration is 0. And if the net force on object is 0, acceleration will be equal 0. If the acceleration is 0, we have two cases. The object is moving with the constant velocity, or it can be velocity can be constant, or velocity can be 0. In these two cases, acceleration equals 0. Now, what is the net force? What is the net external force? Here it is written sum of the forces acting object is the net external force. What is the force? First of all, it's a vectorial quantity. So here we have when we are talking about the sum, that means we have a vectorial addition. This is important. And here, if you look at this the car in the figure, we have a weight of the car, F gravity, reaction of the F gravity, we have F ground. When we are applying a gas, it's moving forward, so there is a force on the forward. And in the opposite direction, always in our daily life, we have resistance, or we can say friction also, because there is not only one type of resistance, but only we can give the name for all one, we can say resistance. So for example, if we draw an object, if this object is moving with the effect of force of the 5 Newton in this direction, all the net force acting on it, it is only 5 Newton. If we have more than one force, we will talk about it in the next page. And also it has another name which we discussed. It is resultant force. Also net external force called resultant force. Just keep it in your mind also. Now let's talk about more about the net external force. Here we have A, B, C, D figures, and the A, let's just imagine the object at the space, so there is no any gravity and there is no any force acting on it, so net force in the A is represented with the F net, it is 0. Now, let's look at the B. At the B, we have object. That object in the right direction, we have 5 Newton force. In the left direction, we have 5 Newton force. To calculate net force, to calculate F net, if the force acting in same direction, we have to add them each other. If the force acting in opposite direction, we have to subtract them. So this 5 Newton and this 5 Newton, they are acting in opposite direction, so we have to do 5 minus 5. So net force gonna be 0 Newton. And in the figure C, here we have an object again. In the right direction we have 8 Newton force. In the left direction we have 6 Newton force. So to calculate net force, we will subtract the numbers because they are acting in opposite direction. 8 minus 6. So net force will be 2 Newton. And in which direction? We can say right direction. And in the D, we have another form of it. Here we have an object and we have a force. That force is the 10 Newton. No, sorry. We have two forces here. Okay, we have two forces here. The one is 6 Newton and they are perpendicular to each other. The other one is 8 Newton. If we have more than one force, to calculate net force, we are doing addition, but here they are perpendicular to each other. In this case, in the previous chapter, as we discussed, we are using Pythagorean theorem. According to Pythagorean theorem, we have F net. So F net equals under root 8 square plus 6 square. So net force gonna be 10 Newton here. I will give you one more example about the net force to explain it a bit more. For example, just imagine that we have an object here and in the right direction we have 5 Newton force and we have 8 Newton force, and in the opposite direction we have 1 Newton force. Let's say, just assume that. How can we calculate net force here? F net will be, if the force is acting in same direction, we have to add them each other. If the force acting in opposite direction, we have to subtract them. So 5 and 8, they are acting in positive direction, so it will be 5 plus 8. And the 1 Newton is acting in negative direction, so it will be minus 1. 5 plus 8, 13 minus 1, it will be 12. So net force here will be 12 Newton, we can say. So if we take the sum of the all forces acting on object, it will give us resultant force, or we can say net force or net external force. Now we will talk about the mass is a measure of inertia. So what is the inertia? Tendency of an object to state its movement, or if it is at rest, it wants to stay at rest. If it is moving, it wants to keep its motion. So this is called inertia, and it is the first law of motion. By the way, first law of motion sometimes called law of inertia. Now here, I will explain something to you. Here, I have one object which is 2 kg, the other object which is 1 kg. If I apply the same force on both objects, same amount of force, F and the F. So if I apply the force on them, what about because their mass different than each other, the first object has 2 kg mass, second object has 1 kg mass. So if I apply the same amount of the force, both objects, these individual objects, their acceleration will be different than each other, because here at the first object I have 2 kilograms, so it is inertia will be more, and at the second part I have 1 kilogram object, its inertia will be less. Like if you wanna try to push any box, for example, just assume that you are here and there is a box here. If this box 10 kilogram, easily you can push it. But if this box is 100 kilogram, it will be hard to push it. So if we have because you are the same guy, you will apply the same maximum force. So if we have more mass, we have more inertia, we can say. If we have a less mass, we have less inertia, simply we can say. So in this case, according to mass, acceleration can change if the force constant. Now I will explain it with the simulation, and I will show to you video about this. Now we reach sample problem 3a. It says Karzan leaves his physics book on the top of drafting table that is inclined at a 35-degree angle. The free body diagram shows the force acting on the book. Find the net external force acting on the book. So here, let's draw it here. This is the book, let's say, and this is the one force F table on the book. It is 18 Newton. And let me change the color. And here, in this direction, we have F friction, that is 11 Newton. And gravity of the book is 22 Newton. And the angle of inclined plane is 35 degree. If we complete this line here, this is perpendicular each other, and this angle will be what? 55. 55 plus 35, 90, plus another 90, it will be 180. And as I told you, if the force is acting in same direction, we can add them each other. If the force is acting in opposite direction, we have to subtract them. But here, 22 Newton force, they are not in. It is not in the same or opposite direction with the 18 or 11. So I have to separate the 22 Newton into components. The one component is this. The other component is this. We can say 22 is the Fg gravity on the book. Let's say this is the Fgx to recognize what we are solving, and let's say this is Fgy. How can we calculate Fgx? What is Fgx? Fgx, it is standing at the adjacent of the angle, so it will be cosine 22 times cosine 55, and Fgy is standing at the opposite of the angle, so it will be 22 times sine 55. And Fgx will be, if you use your calculator, Fgx will be 13 Newton, and Fgy gonna be 18 Newton. So Fgy 18 Newton, Fgx is 13 Newton. So here, if you can see it, FGY and this, they're opposite to each other. So we have to subtract them. In this case, they are carrying same value, 18 and 18. If we subtract them, we will obtain 0 in this direction. And in this component, we have two forces. One is in this direction, which is 13. The other one is in this direction, which is 11. So F net will be 13 minus 11. So it will be 2 Newton. 2 Newton, we can draw it. The angle here, 35. The book is here. So F net 2 Newton in this direction. Now from here, I will solve some questions. I hope you will understand much more better. In this question, it says a man pulling on his dog with a force of 70 Newton directed at an angle of positive 30 degree to the horizontal. Find the x and y component. So this is the force, which is 70 Newton. The angle here, which is 30 degree. And we have to calculate x and the y component of it. Fx equal f times cosine x. So 70 times cosine 30. 70 times cosine 30 is 60.6 Newton. And the Fy is 70 times sine 30. It is 35 Newton. Thanks for listening. Question says a gust of wind blows an apple from a tree. As the apple falls, the gravitational force on the apple 225 Newton downward, and the force of the wind on apple 1.05 Newton to the right. Find the magnitude and direction of the net force on apple. So let's say this is an apple. So this is the force of the wind, which is 1.05 Newton, and it is falling down with the force of the weight, which is 2.25 Newton. And the question says calculate the net force from initial to final, F net, and the direction of it. So F net equal 105 square plus 2.25 square under root. So F net will be 2.48 Newton. And we have to calculate also direction. So this is the angle. So direction we calculate from the inverse tangent formula. Theta equal tangent inverse Fy over Fx. So tangent inverse Fy is 2.25, Fx is 105, and the theta will be 25 degree, but it's actually at the fourth quadrant, so it must be with the negative sign. So the theta will be negative 25 degree. Thanks for listening. In this case, it says a wind exerts a force 452 Newton north on a sailboat, while the water exerts force 325 Newton west. The sailboat, find the magnitude and the direction of the net force on the sailboat. So the one force which is in the north, 452 Newton. The another force in the west direction, 325 Newton. So if we add them each other, 325 Newton plus 452 Newton. So this is our net force. net force, and we have to calculate net force by the Pythagorean rule. So F net equal 452 square plus 325 square under root. So net force will be 557 Newton. Then we have to calculate the direction. This is the angle. Theta equal tangent inverse opposite 452 over adjacent 325. So it will be 54.3 degree. But here it is not at the first quadrant, and so we have to mention this, the angle at the north of west. Thanks for listening. Now we will talk about the equilibrium. This word is important because in the further questions it will be very important and a unique word to solve question. So we have to discuss about it now, because in the question it will tell you the object in the equilibrium, or if the object in equilibrium. According to this word, you are going to solve that question. And what is the equilibrium? Equilibrium, as you see on the picture, the stones look like a seesaw. So they are in equilibrium. That means they are in the balance. So in this case, this stone or this stone, it doesn't move up or down if the both sides equal each other. So here, equilibrium means net force acting on object. We will talk about the net force. Net force acting on object is 0. This is important. If the net force acting on object is 0, previously we talked about that object can be at rest. What does it mean? Rest means velocity of the object will be 0, or that object moving with the constant velocity. So we have one case in the equilibrium. Net force acting on object will be 0 and velocity of the object can be 0, or velocity of the object can be constant. In this case, if the velocity 0 or constant, what about the acceleration? In this case, acceleration will be 0 because acceleration is change in velocity. All this information you have to understand when the question says object in equilibrium. Keep this information in your mind. It will be very useful. Like this, for example, we have object. That object, you are applying a force in the both sides, 5 Newton and the 5 Newton. If you cancel them, net force will be here 0. So we can say this object in equilibrium.